Hello everyone, this is Hajing Tian. In this video, we're learning chapter 6.1 inverse circular functions. In this video, we're learning the inverse function of the trig functions. All right, let's do a little bit review. What is the inverse function? If I have a f function, and normally we will have the input x, we say f of x. But now if we say input a triangle, then I have an output, a circle. Then its inverse function of the f is inverse of f. Then the input is the output of the f function. So now the input is the circle. Then the output is that triangle. So let's see the domain and the range of the f function and its inverse function. So the domain of the f. So domain means all the x value. Let's see. Oh, here is the domain. Domain of the function f is the range of the inverse of f function. So you see, oh, yes, domain is the input, all the x value, and range means output. So domain of f is the range of its inverse function, and the range of f is the domain of its inverse function. So let's use different color. Let's use green. And this is the output, means the range of the f function. Is the domain, is the input of its inverse function. All right. If I can graph my f function, for example, my f function look like this. And then where is its inverse function? The f function, f of x, and the inverse of f of x. They are symmetric along the line y equals x. This is y equals x. Then its inverse function should be here. They are symmetric to each other along the y equals x. And what else? So are all the function has the inverse function? No. The horizontal line test told us if we have more than one intercept, this is not a inverse. This one has no inverse function. So if I have, oh, I use too much space. So if I have a function look like this, and I use a horizontal line test, I have more than one intercept. This is not a, this one has no inverse function. And if I have a function look like this, so this one, all the way going up, going this way. If I draw a horizontal line, so I only have one intercept. So this one, this function has the inverse function. Okay, let's see the function sine x. So the function of the sine x, the graph is here. You will see so the graph of the sine function. Can you tell this is the one-to-one function? No. One-to-one function says if I draw a horizontal line and I have only one intercept, I cannot have a lot of intercepts. I draw a horizontal line. Assume this is a horizontal line. The sine is not a one-to-one function, but I still want to find the inverse of sine function. Can I limit my, or just squish my inverse the interval of the domain between the negative half pi and half pi? So I will not look at this graph. I only look at the graph between half pi, negative half pi and half pi. You will see the blue curve. Yes, this is a one-to-one function. I draw horizontal line. I only have one intercept. That means if I only look at the graph between negative pi over 2 and pi over 2, this function sine x has the inverse function. And if I say this negative pi over 2 to pi over 2 on the interval, on the unit circle. So unit circle starting from the 0, rotate positive and negative direction. So negative pi over 2, this is pi over 2. So if I have an angle, it's between negative half pi and half pi. So my sine has the inverse function. So remember this graph. And how to describe the inverse of sine? We say inverse of sine x or arc sine x. So ARC sine x. This represents the inverse function of sine. And so from this image, you see the blue one, the blue curve is the graph of sine x, axis between negative pi over 2 to pi over 2. And its inverse function is the pink one, pink curve. And the pink curve and blue curve, they are symmetric along the y equals x. Okay, let's see. Find the exact value of the y in each equation. If I have the y equals arc sine square root of 3 over 2, find the value of this value. Okay, so what's the meaning of arc? Inverse function. Find the inverse function of sine square root of 3 over 2. Remember that inverse of all trig function represents the angle. So that means theta, beta equals theta or beta or alpha. That's the angle. So how to solve for the y? I will convert it to the sine function from the inverse of sine, converted to the sine function. Now I'm having the sine y equals square root of 3 over 2. And for the sine has the inverse function. Where is the y? Oh, I said the y is between negative pi over 2 and pi over 2 in these two quadrants. And the sine y is positive. So I must have my angle in the first quadrant. So first quadrant, sine y equals square root of 3 over 2. What is the y's value in the radian mode? That's the 3 pi, so that's pi over 3, no, 3 pi over 3 over pi. So pi over 3 or 60 degrees. Okay, so let's do the conclusion. First, I converted to the sine function, switch the y and the value. And second, I will go to my memory and to see where is my angle y. The sine has the inverse function. I can only have the angle in the first quadrant and fourth quadrant. So it's between negative pi over 2 and pi over 2. So I know the value is positive. It must be in the first quadrant. So I can see, oh, y equals pi over 3. Let's see next one. Let's do the first step. Convert it to the regular sine function. So even you see this is a negative 1. So this is not 1 over sine. This represents inverse of sine function. All right, so sine y equals negative 1/2. Now I will graph my unit circle. The sine has the inverse function in these two quadrants, negative pi over 2, pi over 2. And my sine y equals negative 1/2. Where is my angle? Oh, here in the fourth quadrant, Q4. And sine y equals negative 1/2. What is the reference angle if I only look at 1/2? So the reference angle is 30 degrees or pi over 6. So we say reference angle of the y equals pi over 6. Okay, that means this acute angle is pi over 6. But how to find the actual angle between? So the y is between negative pi over 2 and pi over 2. So the y must be negative angle because in the fourth quadrant. So I'm having y equals negative pi over 6, because I know this is acute angle is pi over 6, but the rotation is from initial. So from initial to this terminal is clockwise rotation. So I must have negative pi over 6. Okay, all right, let's move on. Okay, we will work on the cosine, the function of cosine. The graph of the cosine function is here. And this is not a one-to-one function, so I can only choose one interval, specific interval, to see this is the one-to-one function. So from 0 to pi, this is the graph like this, and this is one-to-one function. And some student asked me why you didn't choose the same interval like the sine. So you remember the sine is between negative half pi and half pi. So if I choose the graph like this, is this the one-to-one function? No, horizontal line. I have two intercepts. That's the reason I only choose the interval from 0 to pi. So if my cosine has the inverse function, the angle's value is between 0 to pi. And the output value is between -1 to 1, because the cosine cannot have the value greater than 1 and less than -1. Okay, let's see. The inverse of cosine, we call it inverse of cosine x, or we say arc cosine x. And the graph of the cosine, if it has the inverse function, is the blue curve. You see the blue curve. And if I draw the y equals x, and the pink curve is its inverse function. Okay, let's move on. I don't have enough space here. Find the exact value of y in each equation. Okay, the same method. So make it bigger. So same method. First, convert it to the regular cosine function. Cosine y equals square root of 2 over 2. And I didn't do the conclusion. Where is the y? If I say is between 0 to pi. If I'm using the unit circle, so unit circle from initial and then to 2 pi. Okay. Oh, in these two quadrants from 0 to pi, because this is pi. Okay, let's see. For the cosine y equals square root of 2 over 2, and I know y if cosine has the inverse function, the y, the angle must be between 0 to pi, and in these two quadrants, cosine positive, I must have the angles y equal in the first quadrant in Q1. And what is the value of the y in Q1? Make a cosine y equals square root of 2 over 2. Y must be pi over 4. Or 45 degrees. Okay, let's see next one. So what should I do first? I need to convert it to the regular cosine function. So cosine y equals -1/2. And the y, if cosine has inverse function, the y must be between 0 to pi. So in these two quadrants, quadrant 1, quadrant 2. So where is the y? In quadrant 1 or quadrant 2? Quadrant 2, because we have negative value. Cosine in second quadrant is negative. So from this part, 1/2, what is the reference angle of the y in the second quadrant? So I must have an angle here. This reference angle must be, so I will put a reference angle. Reference angle must be pi over 3. And then what is the actual value of my angle? What color I'm using? I use blue. So the actual angle is from initial to terminal to here. So I'm using 180 minus, so the y equals 180, or use pi minus pi over 3. So it's 2 pi over 3 is 120 degrees or 2 pi over 3. All right, let's see tangent. For the tangent function, can I say tangent is one-to-one function? No, because I have a lot of graphs. So I draw a horizontal line, I have so many intercepts. That means I need to make the specific interval for my angle. So if I choose the angle between negative pi over 2 and positive pi over 2, between these two angles, then I'm having a graph like the blue curve. This is a one-to-one function because horizontal line, I have only one intercepts. So I can just limit my domain between negative pi over 2 to pi over 2. So can you graph your angle on the a unit circle? Yes, it's between negative, it's too much. It's between negative half pi to half pi. So in these two quadrants, then I have the inverse function for the tangent. The inverse function is inverse of tangent x or arc tangent x. And the output value, the y's value is from negative infinity to infinity, because you see my graph all the way going up, all the way going down. Okay, let's see the inverse function of the tangent. I can graph the tangent first and then draw the y equals x. And the inverse function is the pink curve that is symmetric along the y equals x with the tangent x. Okay, let's see the first example. Find the exact value of y in each equation. So the same method. So convert it to the regular function, which is the tangent. Tangent y equals 1. And we need to find where is my angle y. So for the tangent in the first and the fourth quadrant, negative pi over 2, pi over 2. And tangent positive, I must have the angle in the first quadrant. Then the angle, so tangent y equals 1. So so the y must be pi over 4, because tangent to pi over 4 equals 1. And next one, let's see, what should I do first? I need to convert it to the tangent function. So I have tangent y equals negative square root of 3. And then I need to graph the unit circle. Where is my angle y if the tangent has the function, inverse function is between negative half pi and half pi in the first and fourth quadrant. And look at the negative sign here, negative, tangent negative in which quadrant? Fourth quadrant. So I must have I must have my angle in the fourth quadrant, and I will find what is the reference angle first. So if I need to see what is the square root of 3, tangent to what degree, or what tangent what equals square root of 3. So tangent pi over 3 equals square root. I think I say something wrong. So tangent pi over 3 equals square root of 3. So also tangent 60 degree equals square root of 3. All right, that means I found the reference angle. So RF, reference angle of the y equals pi over 3. But this is the reference angle and my domain of the y. So y is between, negative half pi and half pi. So when it's in the fourth quadrant, I cannot say rotate counterclockwise. I need to rotate clockwise this way. So I'm having y equals negative pi over 3. Okay, so this is the way how we found the sine cosine, tangent is the inverse function. How about the cotangent? So what does the graph look like for the cotangent? We know this graph is a cotangent function. It's a decreasing function. And can I say that this is in one-to-one function? No. Oh, sorry. Horizontal line. I have so many intercepts. This is not one-to-one function. So I should limit my domain between 0 and pi. I cannot say like the tangent between negative half pi and half pi, because if I choose like that, it's not one full rotation. So I'm choosing one full cycle between 0 and pi. So between 0 and pi. Okay, this is so one line, and this is one-to-one function. I can find its inverse function. So remember that if I have a cotangent, for the cotangent, if it has the inverse function is from 0 to pi on the unit circle, 0, pi. Okay, in these two quadrants. Let's see, inverse function for cotangent, secant, and the cosecant. So what is the cotangent? That's cotangent, inverse of cotangent x. And secant is, what is secant? I know that secant x equals 1 over cosine x. Oh, reciprocal of cosine. And what is cosecant? Cosecant. That's 1 over sine x. Okay, if they are related to, so these two relate to the sine and cosine, I can find the sine cosine first, and then I can find the x. Let's see the first example. I'm looking for the arc cosecant -2 over square root of 3. So I can assume that this one equals, how about I say equals theta or any angle, because all the inverse function equals, in inverse trig function, they are the angle. I said theta. And second step, rewrite it into the regular form, a regular function. So I'm having cosecant theta equals negative square root of 3. Sorry, -2 over square root of 3. I'm looking for what? I'm looking for the theta. And what is the theta's value? And cosecant equals 1 over sine theta. Okay, it's -2 square root of 3. So if I want to solve the theta, theta is at the bottom. So let's flip the both sides, make the both sides upside down. So I flip the sign to the top. Sine theta equals negative square root of 3 over 2. Oh, solving the theta from the cosecant, I converted to solving the theta in the sines. So we know how to solve the theta from the sine. So next step. So where is the theta? If we have the inverse function. Okay, in these two quadrants, right? In the quadrant 1 and quadrant 4. Okay, sine is negative. That means my theta is in the 4th quadrant. I'm rotating clockwise. And what is the reference angle? If you see, oh, square root of 3 over 2, that is pi over 3 or 60 degree. Okay, this angle is positive pi over 3. So reference angle is pi over 3. And the actual value of the theta is negative pi over 3. So we solved this one, which is a negative pi over 3. Remember that the theta must be between, so my theta must be between negative pi over 2 to pi over 2. You can also find it from the graph here. So let me erase this because we have no space. All right, next one, find the arc secant negative 2 square root of 3 over 3. This one looks difficult, but we always assume this one equals theta, or you say equals beta. So if I say equals theta, rewrite it in the regular form. So I'm having a secant theta equals negative 2 square root of 3 over 3. And I can convert the secant into the 1 over cosine. Cosine theta equals negative 2 square root of 3 over 3. Now I need to flip both sides because I need to solve for the theta in the cosine, and at the bottom I cannot solve it, so flip it. I have cosine theta equals negative 3 over 2 square root of 3. And what should I do? I can rationalize this expression, multiply by square root of 3 top and bottom. So I'm having negative square root of 3 over 2. Okay, so cosine theta in the negative equals negative square root of 3 over 2. So where is the theta? Where to find my theta if I have the inverse function? Cosine is from 0 to pi. So theta must be in between 0 to pi. Okay, so where is my theta? In the first or second quadrant? Second quadrant, because we have negative sign here. So I must have my angle here in the second quadrant. And from this part, can you decide the reference angle? Because that's a special value. So the the reference angle is pi over 6 or 30 degrees. But this is not the actual value of my theta, because this is angle here. If I'm looking for the actual theta and rotating this way, so I'm using pi. So theta equals pi minus pi over 6 is 5 pi over 6. All right, let's move on to see next one, cotangent. You can use the tangent method to find cotangent, but I prefer you to remember that we did the conclusion, how to find the angle value of the or the inverse function of the cotangent. Okay, first I need to convert it to be the equals theta or equals y equals x, and then convert it to the cotangent function, which is cotangent theta equals negative square root of 3 over 3. And the angle theta must be between where? Between 0 to pi. And then what should I do next? I will decide which quadrant is my angle. Negative. So cotangent negative in these two quadrants, I must choose the second quadrant, because cotangent tangent, they are negative in the second quadrant. Okay, what is the reference angle? So look at this special value. So cotangent of an angle equals square root of 3 over 3. What is that reference angle? It must be pi over 3 or 60 degree. So the reference angle is pi over 3. And I'm looking for the angles starting from the initial to terminal. So the actual value, the theta equals pi minus pi over 3, which is 2 pi over 3. Okay, let's see next example. Oh, pop quiz. What is the inverse of sine negative 2? So if you have calculator, you can find it on your calculator. Or if I say no calculator allotted, how to do this one. So I can convert it to I'm sorry, where is it? Okay, here. So I can convert it to the inverse of sine -2 equals theta or equals y. So sine theta equals -2. Have you seen a sine of an angle's value equals -2? The graph of my sine function is the maximum value is what? Minimum value is what? Maximum is 1. Minimum value is -1. So I will never have a -2 for my sine value. So if you are using the calculator, so if you see, if you are looking for this, what is the question? Let me see. Oh, sine theta equals -2. And if I'm using my calculator to find the sine, inverse of sine, you click second, you click sine, that's inverse, and put -2, close parentheses. What do I have? No real answer, no solution. Okay, if I have the value here is not between -1 and +1. So -2 is not belong to -1 and +1. Then there's no solution because I have no such angle satisfied this condition. Okay, let's see next part. Use calculator to give each value in decimal degrees, round to nearest 2 decimal places. Okay, so let's find what is the arc cosine negative 0.133482122. So let's use our calculator to evaluate that. So this is the inverse of cosine. We click second, we click cosine. This is the inverse of cosine or arc cosine. And the number I need to input is negative 0.13348122, close the parentheses, hit enter. So I have this angle, but remember that, check your mode. This one is the degree mode or radian mode. I will see. So click the mode. Oh, this is degree. So if the question is asking you find the degree of the theta, for example, for this one, if this is degrees, so I will choose this one. Okay. Where is it? Click second mode, and then put this degree on the notes. So let me copy down on my scratch paper. 97.670805 something, and then round to 2 decimal places. So the theta is about 97.67 degrees. This is in the degree mode. But sometimes the question says, if I'm looking for the radian mode, and what should I do? I need to convert my my mode to the radian. So highlight the radian, hit enter. And then we quit. We highlight this one, and then hit enter, hit it again. So this is the angle in the radian mode. So if I keep 2 decimal places, so radian mode, I'm having 1.70 in radian mode. Okay, let's see next one. If I'm looking for the degree mode, so theta equals cosecant this value. So we do not have cosecant on our calculator. So there is no cosecant. What should I do? I need to convert it to the sine, because cosecant is 1 over sine. And this one first, I say theta, convert it to the regular function mode is cosecant theta equals 1.9422833, and the cosecant equals 1 over sine theta, 1.9422833. 9422.833 and rescue the sign. I'm having 1 over 1.94222833, and the theta equals inverse of sine of 1 over 1.94222833. So next time, how to find the theta from inverse of cosecant. So I can make a conclusion that every time I find this, I can find inverse of sine, and then 1 over of this angle, of this value. So I use maybe letters, words represent this. So next time I can use this one. So find the inverse of a sine of 1 over that value. So let's use our calculator to approximate the value of the theta. Okay. So first click second and then click sine. 1 divided by, what is that value? Is 1.9 something? Yes. So let's click 1.9422833, close the parentheses. Okay, this is my angle in the radian mode. If the question says in the degree mode, highlight the degree. Quit. So highlight this one again, hit enter. So this is the angle in the degree mode. So that's 30.9879. So let's put it here. So it's about 30.99 degree. If a ask you to round to 2 decimal places in the degree mode. Next one. So what is the reciprocal of a secant? So reciprocal of a secant is cosine. So I can say, like the previous one, we do the conclusion. Then this one, secant reciprocal of cosine, find the inverse of cosine. And in the parentheses, I just put that value here. And then the y equals inverse of cosine 1 over negative 1.2671684, and use our calculator because our calculator has cosine, sine, and use a calculator. So we are using second cosine 1 divided by negative what? Let me see, 1.2. Okay, I have one more decimal points. 1.267 1684. If there is no mistake here, that this one should be my solution. Then hit enter. So this one is 142.10718. So I can bring the solution here. So the solution is about 142.11 degrees. Okay, so we use our calculator approximate the value of the inverse function. Okay, let's see. Here is a summary. So the inverse of sine, cosecant, tangent, cotangent, cosine, and secant. What are the domain of these inverse function? Excuse me. Domain, they are the range of the sine function. So for example, for the regular sine function, sine x, the range is all the y's value. I know what is the graph of the sine. I can graph a lot. So maximum, minimum value, that's that's the range of the function x. So it's between -1 and +1. So let's see. And the interval, okay, interval in radians. Okay, how about the angles value or the range value of the inverse of sine? It's between -pi or 2 to pi over 2. So you can do this. You can do this. It's between these two quadrants, and from -pi over 2 to pi over 2. And how about cosecant? They follow the same thing, like the sine. So I mean the angle. So the angle is also between -pi over 2 to pi over 2, but 0 is not included because it can never be 0. And it is in the first and fourth quadrant. How about tangent? The inverse of tangent. The domain of the inverse function is from -infinity to infinity, because that's the y value of the tangent. And the interval is between -pi over 2 to pi over 2. This is a conclusion. That means first three functions, they all have the x in these two quadrants. Quadrant 1, quadrant 4. The x is between -half pi and half pi. So the function's value, inverse function's value, can only be between -pi over 2 and pi over 2. How about the other three? Cotangent, cosine, and secant. For the cotangent, inverse of cotangent, the domain is from -infinity to infinity. And the interval, so we did the conclusion, is between 0 to pi. And is in the first and second quadrant. For the cotangent, is from here to here, 0 to pi. Because I remember that what is the graph of cotangent? Decreasing 1 from 0 to pi. So from this interval, then I'm having an inverse function. So I chose from 0 to pi. And how about cosine? Inverse of cosine, the domain is from is between -1 to 1, and the interval is between 0 to pi. Oh, it's still the first and second quadrant. We rotate from initial to pi. And the second is the domain is from -infinity to -1 union +1 to infinity. And the interval in radians, or we say this part is a range. We say this is a range. Oh, the range is here. It's given. So the range is between 0 to pi, half pi, union half pi to pi. So it will never equals pi over 2. Why is not equal to pi over 2? Because that's the vertical asymptotes for the secant. Okay, if I have graph of the secant. So graph the secant, I need to graph the cosine. So for cosine, so for secant, they are head to head. So these lines, they are the vertical asymptotes. So the x value for the secant never equals, pi over 2. And for its inverse function, so y's value never equals pi over 2. Okay, so three of these inverse functions, they all have the value or range between 0 to pi on the unit circle. They are in the first and second quadrant. All right, let's see the first example, example 7. Given the exact value of each expression without using a calculator to evaluate them, how to find these? This is composition functions. So inside of the cosine, we have an inverse of sine, the first one. So how to solve this one? We need to simplify this. We will start from inside. to outside. Inside to outside. Okay, we say we assume that inside we have a sine, inverse of sine 1/2. We say this equals an angle theta because I know that inverse function always equals an angle. And inverse of sine 1/2 equals theta, rewrite it. So sine theta equals 1/2. And in which quadrant sine has the inverse function? I've learned in first and fourth. So positive sine value in the first quadrant. Then the theta equals pi over 6 because this is a special value. This is 1/2. And then maybe let me make it smaller. Theta equals pi over 6 or 30 degrees. How about cosine theta? Because I assume all of this equals theta, but I'm looking for the cosine theta. So cosine theta equals cosine pi over 6. So what is cosine pi over 6? Square root of 3 over 2. So this is a solution. All right, let's see next one. We start from the inside to outside. What is the inside? Inverse of sine negative 2 over 3. I assume that equals theta and convert it to the regular form. Sine theta equals negative 3/2. Oh, sorry, 2/3. So this one is a little bit complex. So this is not a special value. And I know that theta must be between these two quadrants and between negative 1/2 pi and 1/2 pi. So the theta must be in the fourth quadrant because it's negative value here. How to decide the value of the theta? Or how to find the tangent theta? Because we assume all of this is theta. So if I'm looking for the tangent theta, what should I do? So let's use the, I think it's in chapter 3 or chapter 1, 2, we have learned that if I know the sine theta value, can you find all the other trig functions? Yes, we can, because the sine equals what? So the sine equals y over r. We can assume that we can let y equals, in the fourth quadrant, y must be negative. Y equals -2 and r equals 3. Can you find the x value? Yes, I can. X equals square root of r squared minus y squared. And then do the computation. 3 squared is 9. 9 minus -2 squared is -4. This is square root of 5. So I know the x value. And what is the tangent? Using the x, y, r represents the tangent. So the tangent equals y over r. Oh, sorry, y over x. So where is the y? -2. What is the x? Square root of 5. And rationalize this one. Multiply by square root of 5. Top and bottom. We have negative square root of -2 times square root of 5 over 5. So we found the tangent theta, which is -2 square root of 5 over 5. Okay, let's do the conclusion. First, we assume inside is theta. Then from the theta, I can rewrite the sine theta. It is -2/3. And the question is, I'm looking for tangent theta. If I have the sine theta, I can find the tangent theta by finding the x, y, and r's value. Okay, let's see next one. Next one, second arc cotangent negative 15 over 8. So what should I do? This composition functions, I will say first, I will make the arc cotangent negative 15 over 8 equals theta, because inverse function, they are always be the angle in the trig function part. So rewrite it, I'm having cotangent theta equals negative 15 over 8. Now I can evaluate all the x, y, and r's value from the cosine theta, and later I need to find what is the secant theta. So secant theta is 1 over cosine, and that is the r over x. So I need to find r, find the x. Okay, let's do the assumption. We can let the top one. So the cotangent theta equals x over y. So we can let the x equals negative 15. Why I'm saying x is negative? Let's prove. I don't know. I just take a guess. So for the cotangent, where is the so when the cotangent could have an inverse function in these two quadrants. So if I have a negative value, I cannot have the angle in the first quadrant. I must have the second quadrant. For the second quadrant, x is negative and the y's value is positive. Oh, that's the reason I have the x is negative 15. And then let's see, what is y's value? Y equals positive 8. How to find the r? R equals square root of x squared plus y squared. So do the computation. I got 17 because it's 15, 8, and the r must be 17. And what is the next step? I'm looking for the secant theta. Secant theta equals r over x, because the secant equals 1 over cosine, and cosine is the x over r. So secant is r over x. And what is the r? 17. What is the x? Negative 15. So the solution is negative 17 over 5. Okay, let me see my cheat sheet if I made it right. Yes, no mistake. All right, we're done for 6.1. If you have any question, you can let me know. Let me separate the question here. Okay, let me